All right, on the oscilloscope, I'm measuring two identical AC waves. This is coming off of the function generator, and then this is the output of a clamping circuit. A clamping circuit will give a DC offset. So we can see on channel 1, I have AC coupling because there is no DC, and even if there was some incidental one, I want to filter out anyway. And then over in channel 2, I have it set to DC because I want to see the DC offset. I want to measure both components. I want to measure the AC as well as the steady state DC voltage of this channel 2. Now there's two ways you can measure the difference between this voltage. All right, so here we can see we've got two identical sine waves. Channel 1 is my input voltage. Channel 2 is the output voltage of a clamping circuit. The clamping circuit is just like this. We have the function generator. I'm providing 250 hertz. And channel 1 is measuring the input signal. Channel 2 is measuring the output signal of the clamping circuit. So basically, I'm measuring both sides of the capacitor. So if I want to know what this DC voltage, the DC offset voltage that the capacitor is adding to the circuit, there's one of two ways I can measure it. Now the first way, which might be what you're most familiar with, is I can use the cursors. So I go up here and press the cursor button, and then I want to press the cursor button again because I want the vertical and the horizontal. So what I'm going to do first is I want to line up both channel A and channel B, well, multi-purpose button A, multi-purpose B on the same point, or along the same point in time. And then I want to press select. Now I want to move both of these points, one onto the input and one onto the output. Yeah, that's probably about close. So here we can say our delta V between these 2 points is 1.6 volts. Now if we want to confirm that this is actually a continuous 1.6 volts, we can actually just repeat that. So we'll just arbitrarily move the multi-purpose button A and then multi-purpose, I guess they're knobs, over to here, and press select to do the horizontal. And I'm going to move channel B down there, channel 2 rather, and move this one there. So here, again, at this same point, we have 1.6 volts. So now we can say, at least at these 2 points, that it is a constant DC voltage. But the assumption might be that that's consistent. But we can actually measure that and know for sure. So I'm going to turn that off. And so what we're going to use is the math function. So I'm going to press this button, and I want dual waveform math. And in this case, let's see, channel 1 is on the top. So I want channel 1 minus channel 2. So I don't want channel 1 minus, I don't want channel 2 minus channel 1. So I want my first source, A, I want that to be channel 1. I want that to be input. And then channel 2, I want that to be the output. And I want minus. So I want the difference between these. So I want to know if this is a constant 1.6 volts. Now you can see the voltage per division scale for the math is 2. I want to change that to 1. Oops. So it's the same gradation as the other channels. Just like the other channel 1 and channel 2, you can change the label as well. I'm not going to bother with that right now. So now we can measure. So if this is again the 0 voltage reference, and this is 1 volt per division, we can count up 1 point roughly 6 volts. But we can also add a measurement. And I want to add a measurement source. And I want to measure max. Add. Now here this is telling me that I have a fairly nice steady 1.7 volts. Now if you want, we can even clean this up a little bit. We can turn averaging on. And that should filter out all the very small random noise and give us a slightly more accurate measurement. So again, we're getting close to about 1.6 DC. So this tells me, instead of just measuring 2 points of, using the cursors and then assuming that it's the same, you can pretty much see visually that's going to be the case. But we can use the instruments to actually measure all of the points across by doing performing math on the waveforms. All right, that's just a little intro to how to do waveform math.